Greeting to all. So we're going to answering question number 5. Determine the magnitude of the force F that shall be applied at the end of the lever. So this is the lever, the green object right there. Should be applied at the end of the lever such that this force create a clockwise movement. So it been given that the moment for the wall system that will be 15 Newton meter. So, sorry for that. About point O. So point O, it is a point of analysis, which is this point when the theta equal to 13 degrees. So the force being exerted by inclined angle of 13 degree. Go ahead to the pro solving. We need to draw as usual the free body diagram first. So you have a lever like been shown in this diagram, and you will have a force being exerted 13 degree. You have another angle 16 degree at point O. So first you need to indicate what is your axis. So this is my y, and alright, I'm just pick a green color right there to indicate the x-axis right here. This would be my x-axis, I assume. Of course you can assume by your own, but for me I'm using this direction as my axis. Force F direction will be in this direction, 13 degree in this direction. So it's not either as parallel onto x or y. So you need to compute into x and y direction. By doing so, you need to do a not trigonal, but a rectangular of force. Just assume that this will be your force. So you will have a component of y, which is indicated by this line, and you will have a component of x indicated by this line, and the angle of it, there will be 13 degree. This will be the angle 13 degree. So you need to use sine and cos law. So you will get sine 13 degree times by f will be for your y, which will be this one. This is your y component, and cos 13 degree times by f, that will be our x component. So you already have the two components of force. But now you need to compute what is your perpendicular distance, because it's been given that the question given us 15 Newton meter of resultant movement. So we're going to use an equation of movement. In that equation, you need to know what is your perpendicular distance. You know what is a force, so there is a halfway job. Now you need to know what is your perpendicular distance. So for y component, I'm just gonna explain right here. For the x component, this is your acceleration of force. Perpendicular distance will be from this point on to this point. It's not like that, but perpendicular distance for x component will be from here to there. So you need to know what is the length of this line, which is you need to do a sine 16 degree times by 300 millimeter. So you will get 316 times by 16 degree. You need to plus by 15 millimeter, because the perpendicular distance for x component, that will be from here to there, which you need to include 15 millimeter. So that's why you need to times by 15 millimeter, and you will get approximately onto 309.81 millimeter, because 300 will be in millimeter, so the final value will be in millimeter. Meanwhile, for the perpendicular distance for y component, this is your y direction of force. The perpendicular distance is from here to there, from point of analysis to this line. So in getting that, we need to use a cos law, which is cos 16 degree times by 300 millimeter. So you will get 150 millimeter in solid 150 millimeter. So you need to include in your calculation because the direction of the y component will be exerted upward direction. So just imagine that you are statically put your finger at point O, so the y component will make the system rotate in this direction, in counterclockwise direction. So that's why the value will be positive. Meanwhile, for the x component, put on your finger at point O and exerted the force at x component direction. So the system will go around this line, this circle. So it will rotate clockwise direction. So that's why it been signified by negative right here. Because our assumption, the movement will produce a clockwise, anti-clockwise direction as positive. So clockwise direction as negative. So that's why negative f cos 13 degree times by the perpendicular distance equal to the resultant moment for the wall system, which is 50 Newton meter, which you need to convert into millimeter because the distance of our perpendicular distance, they will be in the form of millimeter. So equal to 15 kilo Newton millimeter. So you will get onto 77.6 in the form of negative. It means that the direction will be differ from our assumption, but the magnitude is the same. I think that's all. Thank you.